Good morning, everyone. Hope you all are doing great. So today I am going to solve the index question number 2.6. The question is that H2S is a toxic gas with rotten egg-like smell. We already know about this H2S, okay? In practical, in laboratory, we use this gas in qualitative analysis, okay? So what happened in this question? They told that if the solubility of H2S in water at STP is here given that solubility is in molality. Okay, we know that if we have to calculate the solubility concentration, then we use that term molarity and all. Okay, so here the solubility is given in molality. Calculate Henry's law constant, and we have to calculate the Henry law constant. So first of all, in our previous classes we came to know about a important relationship, and it's that we know that whenever we increase the pressure, the mole fraction is increased, or the solubility is increased, or the concentration is also increased. Okay, so in case of with the help of Henry law, we came to know about the equation, and is this. So it's really very important equation. You must have to remember that. Okay, and with the help of this equation we can calculate this Henry law constant if we came to know about that pressure and that mole fraction. Okay, so now let's try to calculate the value of pressure and mole fraction. So first of all, here it's given that it's in STP. Okay, STP means standard temperature pressure, and in at standard temperature pressure the value of pressure is 0.987 bar. Remember that. Okay, so we came to know about that value of pressure from this STP. Now we have to calculate the value of X. Okay, so how can we calculate the value of X? So here given that molarity is this much, so molarity. So with the help of molarity we know that molarity equal number of mole of solute number of moles of solute per kg solvent dissolve in um, mm, solvent weight of solvent in kg. Okay, so here given that molarity is 0.195 m, which actually means that 0.195 mole H2S. I mean here H2S is that solute. Okay, that H2S present in what is the solvent? Solvent is water. Okay, and the weight is 1 kg, so it's in gram, it's around 1000 gram water, 1000 gram of water. Okay, from this value we can come to know about that that much mole of H2S present in 1000 gram of water. Okay, so we have to calculate the mole fraction of H2S because we have to put this value here. Okay, so we know that if we have to calculate the mole fraction, then there's a formula, and it's mole of H2S in the below the total mole of H2S and water. Okay, so we know that the mole of H2S is this. Okay, so we have to put the value here, 195 mole. And what about the mole of H2O? Please remember that I already teach it in my previous videos that if there's a water mass is 1000 gram, then how can we calculate the number of mole? We know that number of mole equal given mass by molar mass. Okay, given mass by molar mass. I already teach these things in my previous video. If you don't watch this video yet, please go and check them. otherwise it will be very difficult for you to understand it. Okay, so given mass is 1000 gram and the molar mass of water is, we know that H2O, so it's 18 gram, because 16 for oxygen and 1 into 2, I mean 2, there's 2 hydrogen, so 1 into 2 plus 16 equal 18 gram for H2 molar mass. So if we calculate, then the mole is around 55.5. So we have to put the value here, 55.5 mole. So if we calculate this, then we get the value around it's around 0.0035. Okay, so we get the value of x, and we also get the value, know the value of p, and we also get the value of x. So we now it's very easy to calculate that Henry law constant. Okay, so Henry law constant kh equal, now value of kh equal p divided by x. So the value of p is p divided by x. The value of p is 987 bar, and the value of x is 0035. So the if we calculate these two, then we get the value is around 0.095 282 bar. So that's all about this question. So you see that it's really very easy. First of all, we have to read the question very carefully. Then we have to think about that what we have to calculate. That if we have to calculate that Henry law constant from this equation, if we know the value of p and x, then it's very easy. Okay. Okay. Then after that, I'm going to solve the question number 2.7. Intext question number 2.7. And in this question, we get that the Henry law constant for CO2 in water is 1.67 into 10 to the power 8 Pascal. Okay, at 298 Kelvin. Calculate the quantity of CO2 in 500 ml of soda water when packed under 2.5 atmospheric CO2 pressure at 298 Kelvin. So first, it seems like that it's so tough. Okay, but no need to worry. Just write those things, I mean those given things, like here given is k's value is given, I mean that Henry law constant is given 1.67 into 10 to the power 8 Pascal. Okay, and what's the next thing? Here they told that the pressure of CO2. Okay, they given that the pressure of CO2, and the pressure of CO2 is 2.5 atmosphere. But since here it's given in Pascal and it's in atmosphere, so it's very difficult, right? So we have to we have to change the unit of atmosphere into Pascal. How can we change it? That we know that 1 atm equal 1 atmospheric pressure. Remember that, okay? 1.01 into 10 to the power 5 Pascal. So 1.01 into 10 to the power 5 Pascal. Okay, so we get it, the value is around 2.53 into 10 to the power 5 Pascal. Okay, so again we know that the Henry equation is P equal kh x. So we know about that kh, we know about that p. Now we have to calculate x. Okay, so x equal p divided by kh. So p value is 2.53 into 10 to the power 5 Pascal, and the value of kh is 1.67 into 10 to the power 8 Pascal. So the value is around 0.00152. Okay, so we get this much. And now here, given that, well, what we have to calculate? We don't have to calculate that x. We have to calculate the quantity of CO2 in 500 ml. Okay, we have to calculate the quantity of CO2 in 500 ml. So we know, we get the value of x CO2. I mean mole fraction of CO2. Okay, it's mole fraction of CO2. We get that much. Okay, and x CO2 means, how can we get that this one? Like n CO2 divided by n CO2 plus n H2O. So since it's if we are taking these two, then it's become so tough, so we can ignore this one, because see, if we mix CO2 gas in that much amount of water, so it's really very less. The CO2 gas mole is less than mole of water. So what happened? We should ignore this one. We should ignore this since its value is very less. So we should ignore this, and we get the value is around NCO2 divided by NH2O. Okay, so here remember that we know the value of number of mole of H2O is 55.5, but when there's 100,000 gram or 1000 ml is given, but here the value volume is given 500 ml. So if since there's we know that for 1000 gram, we already get it, we already solve with these things. Okay, for 1000 gram we get the mole of water around 55.5. So for 500 gram, we have to divide 55.5 by 2. It's the value is around 27.7. okay, and if you don't want to calculate this in this way, so what you should do, like given mass is if we have to calculate number of mole of H2O, then given mass is 500 gram and the molar mass is 80 gram. In this way you also get this value. Okay, remember that this is the mole of H2O. So mole of H2O is 27.7 mole, and we know the value of XCO2. Here it's, so we know the value of XCO2 is NCO2 divided by NH2O. We get the value of XCO2 is 0.00152 NCO2 divided by NH2O. NH2O value is 77. We already get this one. Okay, and we have to calculate that mole of CO2. That means 152 into 27.7 mole. So it's around, if we multiple these two, then we get the value is around 0.042 mole. So we get the value of mole. Okay, but in this question, what it's asked that calculate the quantity of CO2 in 500 ml of soda water. We no need to calculate the mole. We have to calculate the quantity. Okay, so I mean the mass. So we know that mole equal given mass by molar mass. So the molar mass of CO2 is, for carbon it's 12 and for oxygen it's 16 into 2. So 12 plus 32 is equal 44. So molar mass of CO2 is 44 gram. Okay, and we have to calculate that given mass. Okay, that given mass we have to calculate, I mean that quantity of CO2. Okay. okay, that given mass. So we know the mole is this, I mean that 0.042 mole equal 44 grams. So if we have to calculate the given mass, I mean the quantity of CO2 in 500 ml, gotike I mean that quantity of CO2 in 500 ml equal, I mean this one equal point 0 sorry point 500 ml is equal 0.042 into 44. So the value is around if we calculate these two, then the value is around 1.848 gram. So that's it all about this. Okay, if you don't understand anything, please watch this video for 2 or 3 times, then it's very easy to understand for you. And that's it all about for today. Study well, and if you don't understand anything, please ask me in comment section. Okay, and study well. Thanks a lot for watching.